Okay, so today we're going to continue with Chapter 6 and look at the third section, which involves relative velocity. And this is the last section of this chapter. Okay, so relative velocity, we hit on this a little bit in Section 1. And actually, in the very first chapter, we talked about how motion is relative. So if you are sitting still, you're not moving in relationship to the table, but you are moving in relationship to Earth, because Earth is moving around the sun. And this is kind of the same thing as that. So let's say you're on a school bus traveling at 8 meters per second. Okay, and you walk towards the front of the bus at 1 meters per second, which probably could get you a bus ticket now, so don't do that. So we want to know, what is your velocity relative to the bus? Okay, well, your velocity relative to the bus, so this is u to the bus, is 1 meter per second, right? Because you're walking towards the front of the bus at 1 meter per second. And the bus's velocity relative to the road is equal to 8 meters per second. And so then we want to know, what is your velocity relative to the road? So u relative to the road. So we have to take into account the bus and your motion together. And so we get that the velocity of u to the road is equal to the velocity of the bus to the road plus your velocity relative to the bus. And so it's 1 meter per second, which is u and the bus, plus the 8 meters per second, which is the bus and the road, and that's a total of 9 meters per second. So relative to someone standing still on the side of the road, you would be moving at 9 meters per second. So let's look at the general equation that we're going to use for relative velocity. So this is the velocity of object A to B plus the velocity of B relative to C is equal to the velocity of A relative to C. And so basically what's going on is we've got kind of three different situations. So for example, in the first example, we had the road, the bus, and U. And so those three objects would be represented by A, B, and C. So here is this equation in words, basically, if you want to write, if you like the word definition and the equation definition. So the relative velocity of object A to object C is the vector sum. So these are all vectors, okay, and we're going to assume for the most part they're all in the same plane of motion. But if you have, something in two different dimensions, like a plane traveling and a crosswind, okay, you could still add these together. You would just need to put them into components and use Pythagorean's theorem like we did in the past chapter. Okay, so the relative velocity of object A to C is the vector sum of object A's velocity relative to object B and object B's velocity relative to object C. Okay, and so like we kind of just hit on, you can have relative velocity with motion in two dimensions. This could occur with planes, boats, migrating birds. You could have a boat trying to cross a stream, and the stream, is flowing this direction. And so we would break this up into components, and we'll do some examples of that. So you want to use the skills learned in Chapter 5, which involve vector addition and breaking things up into the components. Okay, and so like I said, we will do some practice in class, but if you'd like to get a head start, here are the practice problems, and then here also is the homework. So a pretty short section, so we'll go over any questions you have in class. Have a good day.